So now you can see that the tables have two entries. One is a token that tells me what the builder is, and the other one is the special positioning rules. But the question you may have in your mind is what about these entries that don't have any markers? They're just 3 underbars. What does that do? Well, I have a function called dump, also from SSK, also extracted from somebody's external code, which I then modified a little bit for my own purposes. And its job is to print the contents of a single table, just the first level. And so if I dump out the resulting ones that have nothing and the resulting ones that have something, we're going to see this. So these here that say entry 1 equals and then it's nothing, that was one of the ones that had basically 3 underbars. So that basically is saying, when I look at this, I know that that means that it's empty. There's nothing in it. So I take this split out table, and then I look at it. I look at entry 1, and if it's a blank string, I know that that was an entry that did nothing. It was an empty blank space on my level. So I ignore it. Let's turn off the dumping thing again. But if it is not empty, if there's something in there, then I'm going to look at entry 1, and I'm going to look for the special marker that is for the player, or the begin marker, and I'll do something special. And what that special thing is I will say, oh, what's my current row and column? That's the real center row and column, which I'll return later. However, if the marker is not B, I don't do this. In each case, if the marker is not empty, I will create a table where I say type, and then I do a lookup, and I'll show you where this is in a minute, based on this value. Subtype, which is entry 2, so this is going to be 1, 2, 3, or 4. And then currently it stores the column as the X and the Y as the row. Because you remember earlier I said on the first pass everything's relative. We don't know the real position of everything in the world. So the best I know right now is that this is a row. I'm sorry, the X is going to be a column value and the Y is going to be a row. But I don't know what those really mean in terms of X and Y positions. I just know this could be like, say, column 2 and row 3. And that's good enough for now. So I'm going to store that information in the table. And what I didn't say is up here I created a local variable called record. And then in record, I create this table. So let's take a look at this bit right here. Let me just load the file again. At the top of this file, I have a table called builder files. And in here, I've done this same kind of like lookup thing. So I create a entry under B that says look for the start file. If it's R, the name of the file is round. And if this is unclear, let's take a look here. In our builders folder, we have coins, monster, player, round, spikes, and square. So this right here is basically giving me a way to convert that one-letter symbol into the name of the builder file that I'm going to use later to do the building. So when we look at these entries, that's going to be square, that will be the player, square, this will be spikes, coins, and monster.
So I have a question for you.
Go ahead.
You used the underbar as a token, you said, to separate the values in the string.
Yes, I use that as a token to separate the values in the string. This will be, and then the function that splits that will return a table with 2 entries.
Right. No, hold on. So I get all that, but my question, I guess, is, was there an unstated reason for using a token to separate the 2 values, or could you have just smashed them together as an X4 or C1 or an M3?
I could have, but then I would have had no easy way to extract. I could have used substring then, string.sub, another function in the string library. But I prefer to use splitting.
Okay.
because I know that later on I might decide to add more details. Like
Okay.
I might expand this to 3 elements, where you know, say oh, I can't even type here. X4Y, why Y has some special significance in my Uber game.
Mm.
Well, it was everything keeps functioning, and I don't have to go, oh, string sub 1, 2, 2, 3, 3, 4. Oh, I goofed up. So that bit of code, no matter how much I expand this later, will always produce a table that can a sequence of tokens.
Excellent. Okay.
So it's just a way that I think, and so I chose to do it that way. But yeah, people could have, in fact, used substring, the
Okay.
substring capability of the string library, in which case they would not have needed the special split function, which they get out of SSK or they can get off the web.
Okay. I thought maybe there was an unstated benefit there that I just wanted to kind of call out.
Nope, nope, nope. Okay, so we got this record, and the only thing that's left to do is check to see if a record got created, and not always will there be one. So we create a variable, doesn't have anything in it. If it's a blank entry, we do nothing, so this stays blank, has nil. But if it is not blank, we create a record with a type, a subtype, and a relative x and y position, which is just the column and row at this point. We take that record and we put it in our table, which we created at the top, right here, and we just say current entry +1, because it's going to be numerically indexed, and we store the record in it. And then when we get done with that, we have, let me find it, sorry, we have this. Not that. So I'm using the table dumping function again, which is going to print out a nice look at our code, or what's in this table. So now when we run this, this is what we get. We get this table that has a bunch of subtables in it. Why is the dumping still on? Oh, I'm using dump, sorry, not printar. So each one of these looks like this now. So we converted these into tables that look like this. We got a type, coins, monster, player. We got a subtype, 1, 2, 3, 4, or nothing if nothing was specified. And we've got well, these have been already converted into X and Y positions, but if I can't turn that bit off. If I had looked at this a little earlier, these would have like 1 or 5 or 6, just rows and columns in them. Let me find it again. So at this point, we got a level file that's got most of the information we need. Well, not a level file, but a level table. So the only bit that we have to do now is we have to go finalize that. The bit where we, now knowing where the player's X and Y position is, we can position the rest of the world relative to that location. So what we do here in this, originally I had all this code separated out, so you see these comments pass 1, pass 2, pass 3. Well, pass 1 happens multiple times now. So for each of the sub tables, other platforms, dangers, pass 1 occurs. But pass 2 and pass 3 only happen once. So the nomenclature is a little bit messed up here because I didn't change the comments. So if people read this, don't be confused. So pass 1 can happen multiple times, but in finalized level, we're only going to call this one time. And pass 2 is to go back over that level table that we created from doing all the other calls. And basically, given that we know where the player is, we do a calculation, and I'm not going to go into it. You can just look at it. It's basically multiply the row or column by a certain amount and add it to this row or column, and that's where the object is. So in a nutshell, if I said that the player is here, and this is the next column over, this column is nothing more than a certain distance away from the player, or a certain distance to the left. It's just an offset calculation based on the rows and columns that are stored in those variables. multiplied by fixed values, which is the size of the gap, and then we add that to the center of the screen, and we subtract the offset of the player. It's kind of goofy looking, but this maps out everything.